So continuing on with the session where we're focusing on MEMS for a sustainable sensorization, I'm about to introduce someone which I'm sure doesn't really need any introduction because she was the recipient of one of our Emerging Leaders Awards last night. But I will give you a short introduction to her for those who missed the dinner. Franziska Kailer joined Infineon in 2018, setting the foundation for the commodity MEMS microphone market activities, and through a wide range of customers in Asia until 2020. She was and remains an integral part of driving the growth of Infineon to become market leader in the MEMS microphone business. She has a Master of Science from the Technical University of Munich, where she majored in management and technology with a focus on finance and accounting, as well as mechanical engineering. And for those of you who did attend last night, you remember that she had this fantastic project working with young children to develop eyeglasses for $1. So I think without further ado, I'll invite her to come and talk to you about the MEMS activities at Infineon. Thank you.
All right. So, hi everyone. Today I'm very happy to talk about Infineon XENSIV MEMS microphones and how we drive audio excellence and pass the way to a greener future. So yeah, my name is Franziska Kailer. I'm head of product management at Infineon Technologies, and it's not going there. I see it there. Yeah, it's changing here on the floor. Oh, no worries. Yeah, it's moving there.
Oh, I see. Yeah, my fault.
No worries. That's fine. So I get 1 minute more, right?
We're ahead of time anyway.
All right, yes, that's the slide. So yes, I'm heading the product management at Infineon Technologies, and what do we do there? Together with my team, I'm facing the big consumer OEMs that you all know, like Samsung, Sony, Bose, all these customers, and also assembly houses. And we do everything from like product promotion, requirement capturing, to like the day-to-day like troubleshooting on supply issues or quality issues. So it's a quite broad range from super operational tasks to defining the strategic development of our customers and product roadmap. And that's what I really like about the job. It's the perfect mix. And what I especially love about working on MEMS microphones is that our MEMS microphones are in a lot of the devices that you use every day. We are market leader, and we achieved 50% market share in 2022 and 2021. So you might find our microphones in your smartphones, TWS, over-ear headsets, laptop, tablets, the conference systems that you use at your company. And lately, our microphones can also be found in hearing aids. In today's keynote, I would like to focus on how we define excellence based on product quality, supply security, and our product innovations that bring TWS and smartphone performance to the next level. And also, in addition, I would like to talk about our next generation MEMS microphone that facilitates the assembly and repair process, so we actively contribute to a more sustainable future. Right, let's start from the basics. A MEMS microphone consists of a MEMS, an ASIC. The MEMS is the outward-facing part, while the ASIC is then translating the change in capacitance to the signal that is then read out. MEMS and ASIC are then mounted on a PCB and sealed with a lid to create the acoustic back volume. In our portfolio, we have our Infineon branded microphones, but we work also with a lot of partners in China, South Korea, and Japan that assemble our chipsets into packaged microphones. We at Infineon believe in in-house design and in-house manufacturing. That also applies to our MEMS microphones. So the design of the MEMS is done in our headquarters in Munich. Manufacturing is dual site in Germany and Malaysia. The ASIC design is done by our team in Austria. And the production is done in Germany. For pre-assembly tests, we partially partner with UTech in Singapore. Our Infineon branded microphones are assembled at Unisum in China, while, and that's important, we have our test engineers cover 100% of the tests and calibration on our own developed test equipment. So why is that? We believe that through having the full ownership from the chipset to the final packaged product, we can provide the best quality and supply security to our customers. So we offer complete product tracing, single communication channel to our customers. We provide the highest test standards and full test coverage for our microphones and can contribute in case of failure with a comprehensive failure analysis using both backend and front-end data. And as you might have heard through the media, Infineon is investing a lot. So we are investing in Malaysia, in Germany, and also in Austria to increase our capacity. And that also will help to increase our microphone production capacity in the future. And also we further look into a geo-diversification of our backend location. So let's now talk a bit about the technology that we use. For microphones, we use single backplate technology and CO2 membrane technology. Starting with single backplate technology, that's the industry standards. So actually, everyone in the market is using this one. It's simple technology, it's quite robust against water and dust, and you can actually bring it down to quite small die sizes. That means you can put it into small packages and it still has a quite good SNR. Let me talk a bit about SNR because that's the key parameter I will use all over the presentation. SNR stands for signal to noise ratio. So if you have a ratio that is higher than 1:1, which equals higher than 0 dB SNR, you have more signal than noise. So the higher the SNR, the clearer the sound pickup, and the better your performance. The second technology that we are highly investing in is the CO2 membrane technology. It's our Infineon IP, so we are the only one using this technology. And this technology sets the benchmark for highest acoustic performance, so highest SNR. It best fits into medium and large packages. By that, the die size is bigger than what you normally would use in single backplate. And we achieve IP57, so you don't really need to use a waterproof mesh. And why do we invest into two technologies, right? You would ask that. We want to stay market leader. So in order to address all the different applications in all market segments, like from the quite sensitive market, cost-sensitive market to the high-end market, we need to have both technologies in our portfolio. So on this graph, you can see the MEMS die area on the x-axis, and on the vertical axis, the SNR performance. So what you can see on the bottom, the single backplate technology is mostly used for more the cost-sensitive applications, TWS, smartphones, and the single backplate size ranges from the 0.8 times 0.8 millimeters to 1.45 times 1.45 millimeters. And you see the SNR range that can be achieved from 65 to up to 69 right now. For the SDM technology, which is used in the high-end applications, like high-end over-ear headsets that provide a really good noise cancellation, or your conference system. We reach up to 77 dB SNR, and the die sizes ranges from 1.45 times 1.45 to 1.7. So what you can see in the middle is the difference in SMR between like the single backpack technology and the STM technology. So you see there is like, a 5 dB SNR difference. So that shows that the advanced STM technology in the SNR and sound pickup. And for both technologies, we try to bring it to the next level. What you also see is that TWS is like the icon mostly used here. So let's talk a bit more about TWS and what we do there. So on the bottom, you see a breakdown of like an earbud. And the little green thing, I hope you can see, that's the MEMS microphone. And what you can also see is that mostly like 2/3 of the space is used by the battery and speaker. So for TWS, it's all about size. And also about performance, because you want to use it when you're on a plane to get rid of this noisy environment. So you're looking for active noise cancellation, transparency mode. You want to have your device able to be aware of the context and location, and recognition of voice commands. And for all these, you need highest SNR. And on the other side, as said, in order to increase the comfort of your earbud, you want to have a reduced size, so it's all about size. And low power consumption, because actually you don't want to charge your device already during lunch break after you had meetings all morning. And you can see performance, size, and power consumption, that's quite like conflicting requirements, and right now we are still managing this quite well and leading in this market segment. And what we now invest into further are two different innovations. So on the one side, we try to bring the SNR to the next level. What means next level? We target 80 dB SNR. That's the SNR level that you can find in studio microphones, using mostly the ECM technology, which is the previous technology used in microphones. And where are we with that? Let's start from the standard microphone, 65 dB SNR. You can find it in like your iPhone. And over the last years, we went from 73 dB SNR in using STM technology in 4 times 3 times 1.2 millimeter package, and we brought the MEMS size down in order to have a smaller package, and we still were able to reach 70 dB SNR. And now our teams are currently working in bringing it up to 80 dB and reach our target of studio microphone quality. On the other side, as that, in TWS, it's all about current consumption, because you want to use it as long as possible. So the second development track for TWS is lowest current consumption. Where are we there? In 2019, we launched a product that has 980 microampere current consumption. We already brought it down by 55% in the product that we launched just last year. And now with the next ASIC design, we will reduce it even further to reach levels below 350 microampere current consumption. So you can see we are quite well suited for the requirements of the TWS market. So next to TWS, let's talk about smartphones. And for smartphones, you all have one, or at least one. So it's still the key consumer electronic. And for us, luckily, audio is more and more becoming essential for smartphones. So why that? The use cases change a bit. Initially, people were more like taking photos, selfies, to put it on like Instagram or LinkedIn. Now it's more about video content creation, and for that you need audio. So video content creation for TikTok, also like Instagram, it's more moving towards video. The second use case is that more and more people are using the voice assistant of your phone, rather than like typing in the text messages. And the third thing that we see is that more and more people try to put up their podcast. So for podcasts, they don't want to buy an external microphone, but they would love to use the microphone that is on their phone already. So that means all these use cases drive a requirement to high performance, so high SNR. And on the other side, and I have talked about this already with a couple of you, the smartphone market is not really that well, right? It's quite down at the moment, and as we at Infineon, we believe that it's kind of only recovering to the long-term average over the next 2 years. What else is not really happening in like making the market skyrocket again is that the smartphone replacement cycle are now like up to 4 years, and it was just 3 years in 2018 and even less before. And the third trend that we see is the trend towards repairability. So we see, for example, the European Commission, that they work towards establishing the right to repair in EU legislation in order to drive a more sustainable consumption. So that means there is a huge requirement for like cost and robustness. So let me summarize. For smartphones, what do you have to balance in order to excel in this end application? So you have to work towards high SNR to enable video content creation, podcast content creation. You have to work to a more robust microphone because people want to use their phone for a longer time. And also they want to repair their phone. And then cost. Component cost, production cost. Every one of our OEMs, they just talk about, oh, I want to reduce my BOM cost, so please give me a price down. And what are we at Infineon doing about it? We have defined a third development track, and with that, we bring a cost and effective solution to the market. What does that mean? It will be, in the near future, we will launch our first microphone using single backplate technology, reaching 67 dB SNR in a 3x2x1 millimeter package. And with that, we can put a check mark on cost, performance, and since we use single backplate, it makes the microphone quite robust against dust and water. So also for smartphone, it looks quite good. I have now talked about single backplate robustness. What we do in order to increase the robustness of the SDM microphone, I want to talk now. So this is what it looks like when you put a microphone into a phone housing. So you have the microphone in the middle, you have a membrane, you have the sound channel, and this is covered with a mesh in order to protect the microphone. And what we do with our next generation microphone is that this will be protected against all these environmental effects like light, dust, compressed air, water jets, ESD, RFI. This will all be done while reaching for studio quality audio. And how are we doing it? 3 things. So this thing will, the microphone, the packaged microphone will look like this. What has changed? We integrate the mesh and the membrane into the substrate. We reinforce the MEMS so it's better sustains pressures events. And lastly, we integrate the passive devices that are currently outside of the microphone into the packaged microphones. So right now, that's also a component that will be then manufactured by Infineon. And you can guess this new design increases the robustness and thus increases the life cycle of the microphone used in your phone. But it has also 2 other positive effects. One is about the assembly. Right now, during the assembly, the microphone is quite vulnerable to liquids, dust, compressed air, and ESD. So you have to put extra care when assemble the microphone, and clean room is mandatory. So only after the phone is assembled and you have the mesh and the membrane attached, the microphone is protected. and with our new design, that changes. So you don't need clean room conditions anymore for the microphone assembly, and also the handling guidelines are quite relaxed. So with that, we can reduce the environmental footprint of the assembly line and make a more sustainable impact. And the second thing, not only the assembly is easier, but also the disassembly. And this helps to make the repair process much more easy and fast. And also you don't need special tooling when you repair the phone because of a failing microphone. So with that, that's how we drive innovation in a sustainable way. Let me summarize. So we at Infineon believe in in-house design and in-house manufacturing because that's how we believe that we can bring best product quality and supply security to our customers. We focus on 2 technologies, STM and single backplate, in order to address all market needs, all end applications, and keep the leaders in the MEMS microphone market. And with our new package microphone design, we also try to put the path into a more sustainable future with our MEMS microphones. Yes, thanks a lot for your attention. Yeah.
Is this on? Oh, fantastic talk. Thank you so much. The sealed dual membrane technology is tremendous advancement in microphones over the state of the art. You talked a lot about cost and the price point and stuff. Can you just give us a rough idea? It looks a lot more complicated than the single backplane. Is it 2x, 3x more expensive? Or?
So you would expect it to be even more expensive than it is. So we can still address like the market needs of like a mid-range performance device that customers are looking into. And we of course have to compete against other competitors that just use single backplate, right? And have to match the cost level. Otherwise, no one is gonna buy our sealed dual membrane microphone. So I think we can quite well balance it.
That's great, it's impressive.
Yeah.
And I also want to apologize. Last night at the awards dinner, I, in the confusion, forgot to hand you the mic when you won your award, in case you wanted to say any words of thanks. I invite you to do that now, if you'd like.
Yeah, thanks a lot. So yes, I just wanted to say thank you for the committee for giving me the votes and all the recognition for the emerging leader. And also I want to thank my management at Infineon because they trusted my abilities to actually drive this business as a head of product management at a quite young age. And you have seen it's quite a challenging market, quite challenging customers, and so yeah, it's an interesting journey for me. So thanks a lot. Yes.
So Franziska, with all of the deep audio expertise that your teams have has Infineon made any announcements regarding MEMS speakers?
I actually don't know about whether we have done an announcement or not yet. Thanks.
I have one question, but
Sure.
I'm not sure. The switch from the membrane being protected to actually being exposed, can you comment on the material system that you've switched from and to in order to achieve that?
You mean like this, to have the membrane integrated into the substrate?
Yeah.
What type?
Did it change, or was it the...
I actually don't know the exact details. So I think we still work with the same suppliers of the membrane. It's just that the substrate and the design looks different. Yeah.
Thank you. So let's thank Franziska again and congratulate her on the award.